Hello friends, welcome to my YouTube channel Prasad Gunaganti. In this video, I am going to discuss about the concept late, early and usual time. This concept is a part of time, distance and speed. So before going through this video, please make sure that you have watched my previous videos on topic time, distance and speed so that you can easily cope up with this video. See, now let us discuss about what is late, early and usual time. So these three words, late, early and usual or exact time. So these three words are defining the time. Okay, see, for example, I have to reach a class by 10 o'clock. Okay, but I have reached the class at 10:15. So we can say that I reached the class 15 minutes late. Okay, I reached the class 15 minutes late. See, if I reach the class by 9:45, then we can say that I have reached the class 15 minutes earlier. Okay, and if I reach the class by 10 o'clock, we can say that I reached the class at my exact time or a usual time. Okay, so these are the three words defining the time. I will explain you this concept in two ways, which is a basic method and a formula method. Pattern of the questions that are asked in the competitive exam from this topic is, see, a person starting from point A to reach point B at 10 o'clock, initially he starts with some speed s1. Okay, with an initial speed of s1, if he travels his entire distance, he will reach his destination by 15 minutes late. Late means he will take time more. So if he has to reach the destination by 10 o'clock, he will reach his destination by 10:15 as he is late by 15 minutes. Okay, later if he increases his speed to s2, he will reach his destination 15 minutes earlier. Earlier means he will take less time, so he reached his destination by 9:45, earlier by 15 minutes. Then what is the distance between point A and point B? Okay, such type of question will be asked. Later, if they has not mentioned the time, then what will be the exact time to reach the destination? Okay, if they provide you the time and the distance, they might ask what should be the speed of the person to reach his destination in time. Okay, such type of questions will be asked from this topic. First example is, a man going on a scooter with 60 kilometers per hour reaches his office 15 minutes earlier. If he reduces his speed to 45 kilometers per hour, then he reaches his office 5 minutes earlier. What is the distance traveled by the man? Okay, in this question, in both the cases, the man has reached the office earlier time. So, say, let us assume that it is its initial point and its end point is its office. Okay, so let us assume that it is his house. Okay, then the question asked is, what is the distance traveled by the man from his house to his office? Okay, see, initially he has started with a speed of s1. Let us assume it as s1, which is 60 kilometers per hour. Later he has reduced his speed to 45 kilometers per hour. Okay, if he continues his journey with 60 kilometers per hour, he reached his office 15 minutes earlier. Let us assume that he has to reach his office by 9 o'clock. Then with a speed of 60 kilometers per hour, he has reached his office 15 minutes earlier. It means he has reached his office at 8:45. Okay, and in the other case, he has traveled with, if he travels with a speed of 45 kmph to his office, then he would have reached his office at 5 minutes earlier, which means 8:55. He reached his office at 8:55. Okay, here what we have is, we have to calculate the distance between his house and his office. So see, we have time difference here. Okay, in the first case he has reached his office at 8:45, and in the second case he has reached his office at 8:55. So due to the difference in the speeds, there is a difference in time interval. Okay, here the difference in time interval is, see, t2 minus t1, which is 10 minutes, 8:55 minus 8:45. So we have 10 minutes difference. If we convert it into hours, it is 1/6 of an hour. Okay, see, t2 minus t1 is nothing but, we know that time is equals to distance by speed. So here t2 is nothing but the distance by speed of the man. Okay, here let us assume that the distance between his house and his office as x. So t2 is nothing but x by 45 kmph. Okay, it is in hours. In the second case, in the first case, he has traveled the same distance, so I am taking it as x, and the speed in the first case is 60 kilometers per hour. Okay, the difference in these times is nothing but 1/6 hour. So from this, by cancelling with 3 on both sides, we get 3 15s, 3 20s and 3 2s. So LCM of 15 and 20 is nothing but 60. Okay, so by multiplying 15 with 4, we get 60. So multiplying 4 on numerator and denominator, we get 4x. Okay, 4x by 60, and by multiplying denominator with 3 and numerator with 3, we get 60 in the denominator and 3x in the numerator, and the LCM of those two is 60, which is nothing but 1/2 of an hour. So see, if we cancel with this 2 to the left hand side, we get 30. So 4x minus 3x is nothing but x. X is our distance between our house and office. So x is equals to 30 kilometers. Okay, x is equals to 30 kilometers. So option B is our answer. See, it is the basic method. Basic method, I have solved it in basic method. In this method, we have lots of steps. So I will explain you this in formula method. Solve the same question in formula method. The formula is distance is equals to product of speeds by difference of speeds into time. Here the given speeds are S1 is equals to 60 kilometers per hour and S2 is 45 kilometers per hour. Okay, here the time constant is, see, in the question it is given that in the two cases he has reached his office earlier. So if it is early and early, we have to subtract the time intervals. So here the time is, he is 15 minutes earlier in the first case, and in second case he is 5 minutes earlier. So we have to take the difference, which is nothing but 10 minutes. Okay, if we convert 10 minutes into hours, we get 1/6 hour. Okay, as these two are in hours, kilometers per hour, I am converting this minutes into hours. Okay, by substituting these values in the formula, we get product of speeds. Product of speeds is nothing but 60 into 45, and difference of speed 60 minus 45 is 15. Okay, 15, these are in kilometers per hour, and time into time, so which is nothing but 1/6 of an hour. By cancellation with 15, we get 15 3 is 45, and cancellation with 6, we get 6 into 10, which is nothing but 630 kilometers. Okay, 30 kilometers. So directly we has obtained the distance. So I has written here 3 to 4 steps, but it is a single step answer. By substituting the values, we can directly get the answer. For explanation purpose, I has written this in 3 steps, but in only one step, by substituting the values, we can get the answer directly. The second example, Mr. Anurag, walking at a speed of 10 kilometers per hour, reaches his school 25 minutes late. Next time he increases the speed by 2 kilometers per hour but still he is late by 10 minutes. Find the distance of the school from his office, from his house. See, Mr. Anurag has started from his house and traveling towards his school. Okay, initially he is with a speed of 10 kilometers per hour. See, if he moves with a 10 kilometers per hour speed, he reached his school late by 15 minutes. Okay, sorry, 25 minutes. He is late by 25 minutes. So he is late by 25 minutes. So he decided to increase his speed. So he increased his speed to 2 kilometers by 2 kilometers per hour, which means 12 kilometers per hour. From 10 kilometers per hour speed, he increased 2 kilometers per hour more. So the speed of Anurag now has become 12 kilometers per hour. Even though he was late to his school by 10 minutes. Okay. Even after increasing his speed by 2 kilometers per hour, he is still late by 10 minutes. So now we have time difference. See, here in this case he was late in the two cases, so we have to take the difference in times. So here in the first case it is 25 minutes and in the second case it is 10 minutes. So the difference in time intervals is 25 minutes minus 10 minutes, which is nothing but 15 minutes. Okay, I am converting this minutes to hours, so I am dividing it with 60 to convert 15 minutes to 1 hour. Okay, so here what I get is 1 by 4 of an hour. So see, the time difference is nothing but, we know that time is equals to distance by speed. So the distance between his house and school be x. So x by, initially he has started with 10 kilometers per hour, later he has increased his speed to 12 kilometers per hour. So x by 10 minus x by 12 is equals to 1 by 4 of an hour. So by solving this equation we get x, which is nothing but our distance. Okay, see, by taking LCM we get 60. Okay, rather than taking LCM, first cancel with 4 on both sides. See, 4 ones is 4, so we cannot cancel it with 4, so cancel it with 2, which is nothing but 6 and 5. So here the LCM is nothing but 30. 5 and 6 LCM is 30. So by multiplying 6 with x and 5 we get 6x, and denominator we get 30, and by multiplying 5 on numerator and denominator we get 5x by 30. So LCM is 30, which is nothing but 1 by 2. So by cancelling with 2 we get 15. So 6x minus 5x is nothing but x. If we take 15 to the right hand side we get 15. So x is equals to 15 kilometers is our answer. So the distance between Anurag's house to his school is 15 kilometers. Okay, now I will explain you the same question in formulae method. See, by using formulae we can solve it in only one step. Okay, see, formula is nothing but distance equals to product of speeds by difference of speeds into time. See, in this question it is given that in both the cases he was late, so we have to take the difference in time. Okay, here the given speeds are 10 and 12, and 10 minus 12 is minus 2. As it is in speeds we can neglect negative, so 2, and the time interval is 25 minus 10, which is nothing but 15 minutes. So I am converting 15 minutes to in hours, so 15 by 60. I am converting minutes into hours, so I has divided with it 60. Okay, see, by cancellation with 15 we get 15 fours, and 4 3 is 12, 2 5 is 10. So directly we got the distance is equals to 15 kilometers. So we have to solve this question in formulae method. Most of the questions can be solved in formulae method, so it is very much important to learn the formulae. The third example is a student walking at 5 kilometers per hour reaches his school from his office 15 minutes earlier, and walking at 3 kilometers per hour he is late by 9 minutes. What is the distance between his school and his house? See, it is similar to the previous question, but there is a little difference in this question. See, a student has started from his house to his school. Okay. Initially, he has traveled with a speed of 5 kilometers per hour. Okay. By traveling with a speed of 5 kilometers per hour, he reached his school 15 minutes earlier. Earlier means he has taken less time. So, 15 minutes earlier. Okay, later he has reduced his speed to 3 kilometers per hour. For reducing his speed, he has reached his school 9 minutes late. He was late to the school by 9 minutes. Okay, see, in the question it is clearly observed that in the first case he is earlier to his school, but in the second case he is late to his school. For example, let us take he has to reach his house at 9 o'clock. See, as he is 15 minutes earlier, it means he has taken less time, so he has reached at 8:45. In the second case, he was late by 9 minutes, so he has taken more time than the previous time. So it is 9:09. Okay, so here the difference in time is 24 minutes. 24 minutes. See, as it is earlier in the first case and late in the second case, or late in the first case and earlier in the second case, we must add the times. So directly we can get from here, we have to, as it is late and earlier or late, we have to add the time intervals, which is nothing but 24 minutes. Directly we can obtain by 24 minutes. If in the question it is late or early, then we must subtract the time intervals. Okay. In this case, we must add the time intervals. So we get 24 minutes. Okay. So these are in hours. So I will convert this 24 minutes to hours. By dividing with 60, we can convert minutes into hours. So by cancellation with 6, 12, we can cancel it with 12. 12 2 is 24 and 12 5 60. So 2 by 5 an hour. Okay. So the difference in time intervals is 2 by 5 an hour. So time is nothing but distance by speed. Let us assume that the distance of the student from his house to his school as x. So in the first case we get x by 5, and by taking difference x by 3 we get 2 by 5 of an hour. Okay, we get this in kilometers per hour, and here we get hour. By cancellation of hours we get in kilometers. Okay, see, LCM of 5 and 3 is 15. So 15x minus 3x minus 5x by 15 is equals to 2 by 5. We can cancel it with 5. Okay, 3x minus 5x is nothing but minus 2x, but we have to neglect minus, so we get 2x is equals to 3 into 2, which is 6. Therefore x is equals to 3 kilometers. So the distance between his house and his school is 3 kilometers. Okay. Now I will solve the same example by using formula. Okay. Formula is distance is equals to product of speeds by difference of speeds into time. See, as it is late and earlier method, see, we have to add the times. So we get time as 24 minutes. By converting minutes into hours, we get 24 by 60 hours. See, the speeds are 5 and 3. Okay, 5 minus 3, which is nothing but 2. Okay, we get 15 by 2 into 24 by 60. By cancellation with 15, we get 15 4 60 and 4 6 24. By cancellation with 2 we get 3. So directly we got the answer as 3 kilometers. See, by using this formula method we can reduce our time in our competitive exams, so which is a profitable thing. So we have to use this formula method in our competitive exam. Look at the fourth example. Walking 5/6 of his usual speed, a man is 12 minutes late. The usual time taken by him to cover the distance. See, a man is traveling certain distance. Okay, he is traveling with a certain distance. He is traveling with a speed of 5/6 of his usual speed. Let us assume that the usual speed of the man as x. Okay, now he is traveling with a speed of 5/6 of his usual speed. So 5/6 of x. Okay, the difference in time interval as he has reduced his speed to 5/6 is 12 minutes. Okay, here how we obtain that 12 minutes is, see, if he travels with his usual speed, he would have taken his usual time. Okay, as he is traveling with 5/6 of his usual speed, he is late. So I am taking late time as LT. So the difference in these two time intervals is given as 12 minutes. From the basic concept of time and distance, we know that speed and time are inversely proportional to each other. Speed and time are inversely proportional to each other. If speed increases, time decreases. If speed decreases, time increases. So here it is given that he is traveling with a speed of 5/6. So if we want to take the time, we can reverse it. Say 6/5 of x. The time taken by him will be 6/5 of x, as speed and time are inversely proportional to each other. So here late time becomes 6/5 of x and usual time will be taken as x, which is nothing but 12 minutes. Okay, the difference in time intervals is 12 minutes. By taking LCM of 5 and 1, we get 5 as our LCM. So by multiplying x with 5, we get 6x minus 5x by 5 is equals to 12 minutes. From here we get x is equals to 60 minutes, which is equals to 1 hour. So option A is our answer. This is how we have to solve this question. Now I will suggest you a short trick for this question. So it is given that a person is traveling with 5/6 of his usual speed. If his usual speed is 6 parts, he is traveling with it 5 parts. It is given like that. So see, S1 and S2, I will take S1 as his present speed, which is nothing but 5 parts, and S2 is his usual speed, which is nothing but 6 parts. Okay, see, the speeds ratio is given, but from the basic rule we know that speed and time are inversely proportional to each other. If speed increases, time decreases. If speed decreases, time increases. So those two are inversely proportional to each other. So to obtain the times ratio, we have to inverse this ratio, which is nothing but time is equals to 6/6/5. So as he is traveling with less speed, here he took more time. Okay, as he is traveling with more speed, he has taken less time when compared to this. Here in the question it is given that the time difference is 12 minutes. So here the time difference is 1 part, which is nothing but 12 minutes. Okay, so to obtain the usual time, in the question it is clearly asked that what is the usual time taken by him to cover the entire distance. So the usual time here is 5 parts, which is nothing but by multiplying 5 on both sides we get 5 and 12, so we get 60 minutes directly as our answer. For your explanation, I has given this much brief discussion. But in competitive exam, we can directly take the ratios. See, it is clearly given that 5 by 6. So we will take 6 by 5, 6 and 5 as our times ratio, and by seeing the question we can take the difference in time interval as 12. So one part difference is 12, so we have to calculate 5 parts, which is nothing but 60 minutes. So we can directly answer the question without using our pen. So we have to follow this method. Fifth question is, if a bike moves with a speed of 50 km per hour, it reaches its destination late by 20 minutes. But if it moves at 60 km per hour, it is late by 10 minutes only. The correct time in minutes for the bike to complete the journey. It is given that a bike is moving with a speed of 50 km per hour. It reaches its destination late by 20 minutes. If it moves with a speed of 50 km per hour for its entire journey, then he will be late by 20 minutes. Okay, late by 20 minutes. But if he moves at 60 km per hour, 60 km per hour, he is late by 10 minutes only. See, he has increased his speed from 50 km to 60 km per hour. As speed and time are inversely proportional to each other, the time gets decreased. Here the speed increased, so the time decreased. But, okay, the correct time in minutes for the bike to complete the journey. See, in the first case he is late by 20 minutes. In the second case he is late by 10 minutes. But what is the exact time for him to complete his destination? Here, from the formula method, we know that distance is equals to product of speeds by difference of speeds into time. Here, product of speeds is nothing but 50 into 60 by 50 minus 60, which is 10, and time here we have to take, see, in the question it is clearly given that he is late in 2 cases, so we have to subtract the time intervals, which is nothing but 10 minutes. 10 minutes. I am converting minutes to hours as these are in kilometers per hour, so I am dividing 10 with 60 to convert it into hours. See, by cancellation 60 and 60, 10 and 10, we get 50 kilometers as our distance. So, his distance travelled by the bike is 50 kilometers. See, with a speed of 50 kilometers per hour, the distance 50 kilometers can be covered in an hour. Okay, in 1 hour with a speed of 50 kilometers per hour, he can travel 50 kilometers. But when he traveled with 50 kilometers per hour, he is late by 20 minutes. It means with 50 kilometers per hour, 50 kilometers he traveled in 1 hour, but it is given that he is late by 20 minutes. So we have to subtract the time interval. So 1 hour is nothing but 60 minutes. 60 minutes minus 20 minutes, which is nothing but 40 minutes. So the correct time in minutes is 40. This is how we have to solve this question. Thank you friends for watching my video. In my next video, I will come up with another topic. If you like this video, then please like, share and subscribe my YouTube channel Prasad Gunaganti. Thank you friends.